Hi and welcome. We wanted to have a talk about precision and about significant digits in our warm-up section because they come up a lot in physics calculations, and you're going to keep noticing that we're a little particular about how many decimal places you give in your answers, and there are rules for that, so let's get you acquainted with those if you don't know them already. So to start this off, let's get a question up here. How long is this line? If you're measuring the distance that an object travels or the size of something, that's a very physics thing that could happen. And if you're going to do that, you need a measuring device. So here we are. And it's easy enough to set up your measuring device on this line. And the fact that this ruler only has marks every centimeter means I'm only allowed to give my answer to the nearest centimeter. When I get down here, really all I should be doing is saying, is this line closer to 13 centimeters or is it closer to 14? I should not be eyeballing and saying that looks like 13.7 or 13.6. Really all I should be doing is choosing between one of these ticks that are offered here. This is called the precision of the ruler. So I'd say that's pretty clearly closer to the 14 centimeters, and so for my first measurement here, I'm going to say that this line is 14 centimeters long. Fine. But maybe we're not happy with that, and we go get a better ruler. And armed with our better ruler, we can come at this line again. And now this ruler has ticks every millimeter. So now, when we get down to the end here, let's get a closer look. Now I'm deciding, is this line closer to 13.6 millimeters, or is it centimeters, or is it closer to 13.7? And clearly it's almost perfect for 13.7, so now we have an answer that's a little more precise. We'd say we have more precision in this measurement because we had a better measuring device. Now we can say that this thing is 13.7 centimeters long. We got 14 with a crummy ruler, 13.7 with a better ruler, and conceivably, you could go get a set of calipers or vernier calipers and do an even better job, and you might decide that this thing is actually 13.71 centimeters or what have you. So the number of digits that are in a measurement gives you an idea how good were the instruments that they used to make that measurement, how much care did the person take in making that measurement. If you take a wonderful ruler, if I go out to measure this line with my wonderful ruler and then I get hit on the head along the way, I might get here and say, well, I can't read these lines because my vision's blurred. All I can do is decide it's 13 or 14. So it's not just about the measuring device, it's also about how capable are you of using it. That can affect the amount of precision that you get in a measurement. So if a number is given with only 2 digits, that tells you not a very high quality measurement. 3 is better, 4 is even better than that, and there are some values like the speed of light that have been measured out to 9 or 10 digits because physicists found that they could nail that value, and so they decided to see how good a job they could do of it. That number of digits, those are called significant digits of a measurement. And we're going to be counting those whenever we're doing a calculation, so let's just get used to that idea for a minute. It's not very difficult, but something like 14, we would say, has 2 significant digits. And because that takes a long time to say, we sometimes cut it down to either sigdigs or we'll just write 2SD. 13.7 has 3 significant digits. 13.71 has 4 significant digits. Oops, sorry. I wrote 13.71. That's not the point. 4 significant digits. So no surprises yet. If you have a number like 50,000, all these digits are considered significant. We would say that that measurement has 5 significant digits to it. If you have 3, 2, 7, 6, 8, that's also 5 significant digits. There's one catch. Zeros on the left are not significant. So if you have something like 0.0035, these zeros are non-significant. We ignore those. 0.0035 has 2 significant digits. This 0.00 tells you that the 3.5 is very small. It tells you what place it's in, but it doesn't really tell you anything about accuracy. So, big thing to remember, I'll write it out. Zeros on left are not significant. Everything else is. So that number has two significant digits, and if you have 0.00060, this has two significant digits. These are not significant, but the 6 is, and everything after it is. Zeros on the right are significant. So that has two significant digits. Happy so far? Okay. Let's do some math with these and see what happens when we multiply or add a couple of numbers with different sigdigs, because some things happen. You will not be surprised to hear. Get rid of that, get rid of that. Don't need the line anymore. Okay. So let's say let's have a rectangle. And somebody's measured this and they found that it's 4 centimeters. And then they measure this and they find that it's 9 centimeters. This is going to be an easy one and there won't be any real surprises with it. Area for a rectangle is base times height, so we're going to be doing 4 times 9. Now, the way we think in physics is 4.0 has two significant digits, 9.0 has two significant digits, so when I get to my area, it also has to have two significant digits, the same as the numbers that made it. So if your mom and dad both had two significant digits, you will as well, which isn't too surprising. But what if one of these people did a super great job measuring their side and the other person did the same? So we have 4.000 times 9.0. If you multiply those times 9.0, well, if you do this on the calculator, it's still going to say 36. How many zeros do we put afterwards? How many decimal places do we get? Well, unfortunately, this amazing value does not help us. You are held back by the worst measurement in your calculations. So what you have to do is look for the measurement with the fewest significant digits. This has 4 significant digits. This has 2 significant digits. Because of this measurement, your worst measurement, it only has 2. Your answer can only have 2 significant digits. So 4 sigdigs times 2 sigdigs, you get an answer with 2 sigdigs. Let's clear that and try a few more. .000. So let's say the person with the 9.0 feels bad and they go out and they do a slightly better job measuring their side now. Now what's the area? 4.000 times 9.00. Now the calculator is just going to give you 36 every time, but when you get to the end and you're giving significant digits, you think this number had 4, this number had 3 significant digits, this is my worst measurement, but it had 3 sigdigs, so now my answer should have 3 sigdigs. We get to pad this out and put a 0.0 now. The fact that this measurement got better means the precision of our answer also got better. So when you multiply or divide, the rule is your answer will have as many significant digits as the least precise measurement. So you look at the numbers that you have and you're saying, which of these has the least sigdigs? This has 4, this has 3, my answer will have 3. We often don't think about this until we're at the very end of the problem and we're writing up our finished answer, and then we just take a quick look back and say, okay, how many sig digs am I allowed to give here? If this number were only 9.0, we'd go, oh, I'm only allowed to give 2 sig digs, so I can't say 36.0 anymore. I have to say just 36. And a really terrible thing that can happen, what if this person really phoned in their measurement and they only gave us 9? What do we do now? 4 times 9 is still 36, but we're trying to give the number 36, and we only have one significant digit to work with. You can't even write 36 with one digit unless you go to scientific notation. And if you do that, well, we'd like to say it's 3.6 times 10 to the 1 in scientific notation, but we're only allowed to use one digit, so we end up rounding this to 4 times 10 to the 1. If this measurement is bad enough, we end up not even being able to say that our area is 36, where it's like we're not even confident enough to say 36. All we can say here is basically it's about 40. That's what really bad measuring can do to you. So always look for a number with the least significant digits, and that's how many you give in your answer if you multiplied or divided. Now, there's another rule for adding and subtracting, and it comes up way less because relatively few of our physics formulae involve adding or subtracting, but in the interests of completeness, I'll show you how that works too. If you have two numbers that you're adding, let's say we have 4.005 and then we have 2.71. When you're adding or subtracting, you do not count significant digits, you count decimal places. If you add or subtract, sorry, I said subtract, I wrote a division sign, I don't know where that came from. If you add or subtract, you take the number with the fewest, not significant digits, decimal places. And answer has that many decimal places. So 4.005 plus 2.71. If we were adding this together, we would normally say, let's see, we'll put a 0 there just to fill things out. 5 plus 0 is 5, 0 plus 1 is 1, 0 plus 7 is 7, 4 plus 2 is 6. This is the answer we would like to give, but I regret putting that 0 there because it's important to look at the original numbers. We were originally given this number with 3 decimal places, this number with 2 decimal places. I'm only allowed to give 2 decimal places in my finished answer, which means I can't say 6.715. I have to round this to 2 decimal places, which means I would give 6.72. Try a couple others. If we have, say, 6 plus 2.1597884, surprise, when you add this up, here's the answer we'd like to give: 4887951, and finally here we get 6 plus 2 is 8. This is the answer we'd like to give, but 6 has 0 decimal places, which means our answer is allowed to have 0 decimal places. All we're allowed to give for our finished answer is 8. Because this person didn't bother to measure their tenths or their hundredths or their thousandths, we can't be confident of the tenths or the hundredths or the thousandths in our answer. All we can do is say 6 plus 2-ish equals 8-ish. That's all the precision we get. Now, if this 6th person, whoever measured this, is ashamed of their laxity and they go out and find this is 6.22, now we can redo our calculation. Now we get 4, 8, 8, 7, 9. 2 plus 5 makes 7. 2 plus 1 makes 3. 6 plus 2 is 8. Now, because this number has I keep trying to say significant digits, two decimal places, now we can give this answer to two decimal places and we would round it to 8.38. Right? We had 37, and then we look at this digit and say, if you're 5 or more, we'll round up. We do indeed round up, so 8.38 would be our finished answer. All right, so if it's times or divide, you're looking for number with the fewest significant digits. And if you're adding or subtracting, you're looking for the number, it's almost the same thing, the number with the fewest decimal places. And like I said before, most of our physics formulae are about multiplying and dividing stuff. They're things like VIT plus 1/2 AT squared, where most of the calculations are multiplication or division. You're going to be using this one a great deal more, so significant digits are going to be your primary concern. So keep that one in mind, and I will try to remind you in all of my demos, and if you have any questions about it, your instructor's right there. Please talk to them, and they will be happy to sort you out.